Hello, welcome to another devlog for my 2D space game. Starting off, I want to fix this issue. We have a battery up here with 2000 power, a storage on the left here with some iron, and a battery in the car here with 2000 power. Let's move out the power into there from the car. So now that has 2000 power, the car is empty. And now trying to fill the car doesn't work like it should. We only get the 2000, and that was from the storage. And we do it again, and now it fills up the rest. So I'm trying to hunt down why that's happening, running some tests here. This one passes, and we can see what it looks like. When it starts, I put 100 power in the left, 100 power in the right, 0 in the middle, and then I call it, and that works fine. It transfers from both at the same time when we call fill storage. So that's not the issue. So it's something to do with the zone. So I wrote this test, and now we have the zone, and we have two storages outside, and this one ends up like this. This is really strange, I think. That's not even filled. Oh, no, I think I did it wrong. The top one has 162, and the left one has 38. That could be this volume limit, but then why would this pass? No, but I realized I'm actually trying to fill the top. Oh, yeah, I did try to fill the top one, but then that should have been 200 instead. But whatever. Let's try to fill the one in the zone for now. Same thing there. 162. Everything connects. 38 and 38. This is so weird. Try to fill one on the left. Try to empty this 38 there. Wait, it's being mixed up with the worth. Oh, I did eventually manage to fix that whole traversing issue. It was pretty complicated, but I think it's working pretty well now. I've also cleaned up the menus. We now show some information about the volume and the mass. We can go into a specific resource like this. We can see how it connects. We can use the buttons for this specific resource. So we can empty and fill up, then we get the full even. You can see the iron here, it weighs a bit more. We can fill this up with all the power, and then this one is gonna be empty. We can't drive it. Then can't fill it now because the zone isn't active. We have to focus it currently, and now we can fill it, and then we can drive away if we want to. So we're getting really close to having a version that I genuinely believe could be fun to play. Like the previous releases, they've been mostly just to make sure it's possible to release a version of the game. But now we have like a lot of the key features in place, and I'm really excited. One of the things I did as well is when we have a cost for a module, let's turn on God mode and return this here. When we have a cost for a module, then the worth is shown there, but the mass of that worth used to be able to exceed the mass of the shape, like it wasn't connected in any way. But now I'm actually limiting it. So if mass is enabled, like it's supported, the game is supported to have resources without mass. But I believe it's gonna be a fun concept that resources have a mass to it. Anyway, so now we can see like this is 5 kilos right there. 5 kilos worth of iron. Or no, sorry. I'm not sure it's... Oh, it's probably 100% pure. No. So let's see. This is 5 kilos in the total weight. But we don't know the exact weight of the iron. But when we delete this, we're going to see how much this changes from 75. So 78, so it's 2.5. So it's the gyroscopes are 50% pure. So I've implemented a multiplier to when we define modules costs and worths. So the default value is just 0.5. If it's 1, then the total sum of the resources in the shape is equal to the shape's mass. And I think that's pretty cool. So that can allow us to like create mineable rocks of different purities, because I was afraid that we would have the issue that you would actually be punished to convert a rock to resources, because then it would weigh more and it would cost more to transport. But now, if it's 100% pure, it's going to be the same weight, and otherwise you're going to make it lighter if you actually convert it to resources, aka deleting it in a zone. So the question is, what do I want to focus on finishing for this third release? So I want to make every module have a cost. I know that much. And probably create some more modules. For example, a magnet plate consumes power to be activated, and it would attract nearby shapes, and that would allow you to lift things. A piston would be really cool, but I'm afraid that might be a bit too complicated. Might be a bit of a project itself. And then get some rocks spawning here to the right. We can just make them circles for now, but later I'm gonna want more interesting shapes, of course. Yeah, and then I'm gonna like do a bunch of playtesting, make sure it's somewhat balanced, and introduce some new resources like maybe copper to make batteries and gyroscopes, and maybe lithium is required for the batteries. I don't know. I noticed this little bug. Resizing the wheel works properly like this. It uses up the storage for iron there. But then when we start touching the battery, we can still keep going, and it's adding more stuff to the wheel, even though it's not increasing. Might be as simple as this. We have these two hooks when we resize, and I haven't specified the order. So let's just say that this comes after. This is when we actually do the consuming of resources, and then we should make sure it's valid for that. Perfect. That was an easy one. I've added a bunch more resources. We have silicon, copper, and iron now for this battery. We also have a bunch of that stuff in the storage. I removed the battery up there, and oh yeah, I should add power to there too. But now let's resize this battery. You can see the worth there. So it's now worth 1 silicon, 29 copper, and 5 iron. If we make it smaller, now it lost the silicon, and you can also see that the volume is increasing, or the percentage volume, and there it lost the last iron. So this is really nice. I'm very happy with this. So when I set the price for the battery right here, I just set it like this. And this isn't like an exact amount. This is just quotas, or ratios rather, depending on the mass of the shape. And this like automatically makes it so we can set more and more rare resources as the cost when you want to build bigger stuff. Like we could just make it a single resource, and then you can build it as big as you want if you only have the resource. But like this is perfect. It's like if you want to go beyond this area, you're gonna need iron. But below that, you only need copper. And then you go beyond this area, like surface area, then you're gonna need to start using silicon. I did see this bug, or it's not a bug, but if we, this one has 2000 power in it, and if we make it smaller and make the volume larger than the capacity, then we crash it like this. The question is, should we prevent it from being resized if it has too much stuff? We're gonna show messages and stuff. Like if you make this touch there, then there should be a message like colliding with shape or something. I don't know. But then same if we reduce it too far to stay with the same theme, we should probably just prevent it from being resized. Let's see if this works. Yeah, nice. Awesome. So let's fix this other bug. Yeah, I did consider this. We have had the same issue down here. I'm subtracting the collections, which is a bit naive. I should be looking at the volume remaining instead. All right, let's see if it works. Can we resize this however we want now? Yes, we can. All right. So there's actually free. Let's empty it. And then we can, yeah. So it should probably never be free. Would that define the minimal size then? Because right now I have an arbitrary minimal size. So what would the minimal size for the gyro be? Right there. And that only depends on the weight of the resource. So we can use both. Like I'll keep the minimal. Oh, you can resize even if you don't select. Didn't realize that. So that's another polish I want to fix, but that's very good. So, but let's prevent things from being free. And that's easy to implement right here in our post resize hook. We can just make sure that the cost isn't empty. Very nice. And let's make sure it works. Nice. I've improved the menus further, and now we consolidate large numbers to use prefixes. So 5k power there, for example, and should probably show the exact number when we open it up. But then let's check out the build menu. Let's see if we want to create a battery now. We can see immediately how much it's gonna cost, and it's always been based on how zoomed in you are. So if you zoom in, it's gonna be smaller, and it actually reflects instantly now. I guess I could also say if you can build it or not. because it could know automatically. Then the button could go gray or something if you can't afford it. Then let's see, we have 220 scrap, 120 copper. So we can't build either of these, but we can build a battery. If we don't make it too, no, we have copper as well, so we can make that battery there. Then let's see how big we want to make it, something like that. And then let's make a functional one. And oh, we can't make a gyroscope because we don't have any iron. Okay, so let's change gyros to use copper instead. And for really big gyros, we introduce silicon there. So now we can build gyroscopes. Because I want the user to start with minimal resources. So it's gonna take a lot of balancing and playtesting, but it's kind of fun. Let's see if we can create a car here. All right. Oh, hold on, we haven't fueled it up. So just fill the storage, 4.7k power, and now let's focus it and let's leave. Can't drive too far. Oh, it's so wobbly. That's cool. I did put the pivot joints in the center. I do kind of like that. This is cool. So maybe like remove some of these starting resources. Well, we still need to bring stuff back. So I think next up I wanna actually create resources that can be found outside of here. Oh my god, this has been... When calculating the cost here, I'm doing it very unoptimized, but I thought it would be fine. I'm actually creating each shape and then using the cost and then deleting the shape, which I thought would be fine. But I noticed it's leaking memory, and I've been struggling with this for many hours. There's one cleanup that happens, but then this is just gonna keep rising now. So tricky to find. And I've been trying to catch it with like tests and stuff. And here I have this explore function so I can see all the attributes. Oh god, that's bright. Whoa. So I've been looking through all the attributes to see if there's any reference preventing garbage collection from working. And eventually I realized it's the roots. I'm keeping track of all the body roots so that we can propagate the gravity, because the propagation has to start somewhere. So I was keeping a reference of all the bodies that don't have parents, because they're the largest ones. They're not gonna receive any gravity. But when deleting, I wasn't deleting that reference. And I've been trying everything here. I was doing a quick FPS test and I noticed this method is being called way too often, and it's a pretty heavy method. So I wanted to add a cooldown to it, but I realized I want to be able to also cache it. So if I return true, and if I call it within a second, then I want to get true. And then when a second has passed, we can get the fresh value again. So I just made my own method for this, or decorator, and it seems to work nicely. So let's see, we have this car here, and turn on God mode. And let's make the car fall. You see, it takes a little bit for it to create those lines. Those are the orbital lines. But if we drop it now, then it takes a little while for those lines to disappear, which I think is pretty fine. And that drastically improves the FPS. I want to clean up the controls menu because we have a bunch of debugging. I want to create a magnet action. But before we do that, keybinds here. So I want to introduce maybe just a simple debug flag for keybinds like this, and then we can filter them out. Ended up adding a speed flag as well, and then adding an ignore method. We can check that whenever we yield all the binds. And running this, we can now enjoy our much cleaner controls list, while also easily being able to toggle those keybinds with the view flags. And this is also a system I'm gonna improve in the future. We have a lot of these magic variables that should be easily changeable when running and developing the game. Something like console commands or something in that nature. Well, it's just gonna be settings, I guess. Yeah, I guess they're gonna be the basis of the settings, and then some settings will be developer settings. So that's all cleaned up. So now I want to add a magnet action. And this one is going to be unique or it requires a unique functionality because I want to be able to toggle it on. So you should be able to activate the magnet and then leave the vehicle or whatever it is. And then it should stay powered. So it's the same logic as with the action, but we can not longer only rely on holding the keybind key. But I want to generalize it so it works for any keybind. So I'm just thinking, what if we, like for a thruster, for example, I should show the actions here and then expose buttons to actually trigger the action and toggle the action. So like we could toggle a thruster to always keep firing. Got a basic magnet working. So this one has the magnet basic action, and we can activate it with the X button, and that consumes power. So now since we're in the zone, we can drain the battery over here. And if I drop it here and activate it, I think it behaves decently. Yeah, it's pretty cool. So it attracts anything. And I guess that could be an interesting idea that we only make it attract certain shapes, right? But whatever. For now, let's make it attract anything. And this is like, it's very similar to the gravity, except this is working both ways. But let's add a single circle here and activate it there. I'm just holding the key now, and then once they get close enough, they get exponentially stronger. The built-in button has some limited functionality, but I found I can use the onEvent method to get my own on-hold functionality. And using that, we can create some extra buttons in the context menu when we click a single shape that lets us simulate the keybinds just by clicking and holding here. And I'm thinking this is where we could provide a toggle functionality. I didn't want to clutter the menu, so now we have toggle instead here. Let me quickly make it show the name of the key as well, or the name of the keybind. See if that works. Nice. So now when we press here, we can just let go and watch that thing spin. If we press, we should be able to cancel it. Toggled key name. Nice. Now I can cancel it. Let's go the other way. Now that's gonna continue just going there. Or no, it's not. It ran out of energy, of course. Yeah, that's pretty cool. So I'm trying to work on the extra resources you can find outside here. So we got a boulder worth 13 scrap out there. So this is the kind of goal I'm striving towards right now. Creating means to be able to retrieve that boulder. Now with the magnet working somewhat, I want to add a powered pivot joint. I realized that this might be the key to allow arms moving with precision. So I got a new joint powered class inheriting from pivot joint. I've been trying to wrap my head around how it's gonna work, but I think to simulate a joint opening and closing, all you do is apply equal and opposite force to the rotation of both bodies. So I'm hoping that's gonna work, regardless of whether one is heavier than the other. I guess we'll find out. But then the idea is we can set a target angle, and then we're gonna ask it to try to hold that angle. And then we can change the target angle with a keybind. And focusing this for now, we can make it close. This is a pretty good start. Got a nice little crane structure class there. Let's instead try to affect the target angle instead of applying force directly here. And then we'll apply force in each step instead. But for now, I'm just applying straight up torque with this temporary keybind down there. Working on the powered pivot joint. These two are connected through such a joint in the center there. And I can use the 1 and 2 keys to control it. And I've added a max torque here. I still need some balancing, but it's getting there. Very happy with this. I've been tinkering with balancing the forces on this, and it's multiplied by the moment of the body, so it should work for any shape, which is nice. But I was changing these numbers by hand, and I thought there's got to be a better way. And then I realized I've done something similar before, and it's a very powerful idea. It's the idea that in any place in the code you can just write a function call instead of the number, and then a slider appears influencing that number in runtime. So I actually got that working here, and this lets me play with the, it's not PID, but something similar, because I'm using just taking the difference of the target and the current angle, and then the first derivative and the second derivative. And yeah, you can see if you reduce this one, it's gonna start going down, make it much stronger there, then it starts overshooting a bit. Then we can turn up the first derivative, and now it's catching itself a bit better, like it's overshooting a bit much. Then we can turn up the second derivative as well. Ooh, like that looks pretty snappy. And then we can play with the max torque. If we reduce that, It's very sensitive. That's pretty cool. Let's see if we can attach a shape to this. Maybe let's add a counterweight here first. Pause. Let's add that to there and add a large counterweight to here. Whatever. Let's play. Ooh. Yeah. Now let's turn up the torque slowly. Oh my god, this is so cool. So the max torque could be defined by like the quality of the joint. Because right now the joint is either there or it's not, but I'm thinking I could introduce like same as when we make shapes larger and smaller, they cost more resources depending on how large they are. Perhaps if we make this something similar with joints, like the cheapest one is going to have the lowest maximum torque. But if you just pump more resources into it, it could get a higher max torque rating. But then the weight should also increase, and that's tricky because joints always connect two bodies together. So where do you distribute the weight? If the joint is attached to the planet, which would be really hard to do because you need a zone encapsulating the whole planet. But if that was the case, or no, you don't, because you're gonna be able to weld things to the planet. So never mind. Yeah. So where should we just put half the weight in the center of the planet? I guess it makes sense. Doesn't really matter. But the thing is, we can't just make the weight disappear, because then you could just pump all your resources into the joint, and then you can cheat your way to haul mass around by hiding the mass in the joint and then deleting the joint and getting the resources back. So maybe just spreading the mass 50-50 in each body, or like my fiance suggested when I rubber ducked her. That we make it proportional to the mass of the body. So if, yeah, like here for example, this body, oh, we can just check like this. This weighs 25 kilos and this weighs 4 kilos. So then this would just get 1/6 of the joint mass, and this would get the remaining 5/6. But then if one of them changes size, we have to update the mass there. Ooh, that gets complicated. So maybe just always 50-50. Anyway, this slider function felt very daunting to try and do alone, and I try not to use AI in the game because like it takes the fun away from it. But I've used it for the orbital mechanic math because that stuff is way over my head, and things like that, and like sometimes very specific issues when I get stuck. But mainly, I like doing it myself. That's where the fun is for me. But the slider method is one of the exceptions I'd like to make. So I had Copilot, my current favorite AI, is pretty good. It came up with this after a few iterations, and this just lets me write slider like this. And then we set the default value, minimum value, maximum value, and an optional name. And then we get this slider here, letting us change the values in real time. This makes it so much easier. Like otherwise I have to change the number, rerun the game, and keep iterating. But here we see the direct effect. Very nice. Yeah, so let's lower this. Let's try lowering it. It's behaving a bit differently now with the increased mass, I think, even though I am multiplying it by its moment. Apply torque. We just multiply the force by the moment and then we limit it. Are we hitting... Oh, we could be hitting the max torque. Let's just turn that up for now. Yes, we were hitting the max torque. Now it's shaking. Okay. Well, that's also a bit concerning because it wasn't shaking before. Oh, it's getting worse. Let's turn this down a bit. It was down to like... here before 30,000. I thought it was pretty nice, but that's not stable now. Huh, what's up with this? It's not having any effect though. Is it disconnected? This was working, but nothing else is working, surely. No, it's active, it's active. Very strange. Why would it start shaking now? Because the moment is updated. We have the there, we have the joint here. I'm trying to understand how the hinge applies force to the bodies it's attached to. Well, it's like, I call it hinge, but it should work in any scenario. So like if we have the car again, then these two bodies could be having a pivot joint in the center of the wheel, and then it's not really a hinge anymore. From the perspective of this hinge, it can either open up or it can close. So I was thinking perhaps you just apply an offset force perpendicular to the center of gravity at the center of the pivot joint. So let's say we want to close this, and the force we apply to this right shape would be pushing it that way, but that doesn't make sense because right now I only apply torque around the center of gravity. But the issue is if we have a much larger body here and a tiny arm here, the pivot there, then you're gonna rotate this whole body over there just because there's a tiny thing attached over there. So that doesn't make sense. So then an option is, what if we apply torque on the position of the joint? So let's take this right body again, for example, and we want to close it. So like close it like that. And we apply force. So applying torque with when we only have apply force is that we apply force twice, but in opposite position, offset symmetrically around the point. And that's going to cause this shape to try to rotate around this point. That's going to make it pull up around there. So that kind of makes sense. But then what I'm afraid of, say that there's no gravity here. Let's just simplify this for now. If we have this configuration and then this is closing, I think the pivot should actually move. But I'm afraid that if I apply force like this, if I apply torque based on the position of the pivot, then that's not gonna move at all. So that doesn't seem right either. Okay, so scratch everything I've talked about. I should have had a better look at the built-in joints. This is the damped rotary spring, which has a rest angle, stiffness, and damping. So combining that with a pivot joint, let's actually remove the pivot joint and see how this works. Okay, so these can be apart now, and they're still just connected to keep a relative angle. That's pretty cool. But this might be exactly what I want actually. So I might not even need to deal with all the calculations myself, which is always ideal. There's also the gear joint, which is pretty cool. Looks like this, and it's just fixed. There's no strength to it, and it can handle any weights, I think. You can even lift this up a bit. Careful not to smash the bottom piece. So that's pretty cool, but it's gonna be like infinite strength, and I'm not sure that's what I want, but it's so good though. This damped rotary spring was pretty hard to balance. Introducing some hook calling to the joints, we can now actually see where they are. And this setup here, we got actually two joints. This is what I want to clean up next. You can see I can actually open and close these. I'm using the gear joints now. We have three options. Me applying custom force to a normal joint, so just a single joint, but that requires very advanced math that I'm not capable of. The other option, well, at least if we want to normalize it for any body setup, because like it's not enough to take the moment into account, you also have to take the distance of the body into account, and then the angles of the joint to the bodies and stuff. And yeah, it would be great to avoid all that. So then the other option was the damped spring joint, which worked okay, but then you have to tune the strength and the damping values, which once again we gotta do advanced math to make work for any setup. But this, the gear joint, works for any structure because it's just fixed. So that's a downside because I wanted it to respond to a heavier load and like kind of start sagging if it's too weak. But it's not that important. And anyway, there's already zero structural integrity in the game. Like you can build super thin into super thick and then super thin, and it's not gonna break at those super thin parts, for example. So it kind of goes with the theme to focus on the gear joints that locks the angular velocity of two bodies together. But that brings me back. So that's the third option, and that's what I'm gonna focus on. But that means we have two joints now. This is the pivot joint down there, where the position is actually correct. But I had to, for this other joint, or like they call it constraints in the engine, it doesn't actually have a position like the pivot joint does. So there I'm just making it use the average of the two bodies it's connected to. But when drawing this, or when creating this, let me show you this actually. Here we have the options, and when creating the gear joint, we actually create a normal joint, pivot joint first at that position, and then we add the gear joint as well. So it's two joints there. But I'm gonna want to make this gear joint belong to the pivot joint somehow, or I don't know. Yeah, because then, yeah, they should be combined into a single joint, because I can't allow these to be connected through a gear without the pivot joint, because then they could be on the two different sides of the planet and still rotate together. So that's not gonna work. Same with damped rotary spring, works similar. So we would have to attach the gear joint to the pivot joint somehow. Maybe something like this could work. And then we check if a joint has a parent, we're not gonna draw it. And if we delete a parent, we need to delete all its children. But I don't think we need to do something fancy. We don't need support recursion or a hierarchy, whatever. Just a single parent value and keep that simple for now. Okay, nice. So I introduced the joint parent here, and I'm trying to see if we can actually serialize it using the serialization technique inside Pymunk itself. Worth a try. So let's see, I added a joints top here. That's all the joints that don't have any joint parents, and that's what I now use when I call onDraw. And I also updated the draw function to make it a bit prettier. So now we have this. That's really cool. So now I want to make it interactable. I'm not sure I even need to make it interactable actually, because like we already have the access point here, but we should make this only use the top joints. And to create a new joint, we currently only have pivot joint there, so let's just add the gear joint there. And then call it a day. We don't need to interact with this yet. Or even better, just add a method to our joint set class and use this here instead, for example. And because we also have these, like if we have a set of bodies, we can get the set of joints from that. So instead of implementing the filters and all of those different methods, we just put it on the source set. So if we have a set of joints, we can just get the top joints like that. All right. So now it should look like there's only one joint. Yeah, very nice. And it should be able to delete. Yeah, disconnects everything because that also calls delete on all its children there. Perfect. And finally, let's add that over here. Create. Oh, I guess this is gonna require some work to change which type of joint we use, because now it's kind of hard-coded to use a pivot joint. All right, so let's stop there for today. Cool. Yeah, looks good. Well, let's push that up to GitHub and call it a day. Very happy with this progress. Very nice. I've cleaned up the joint creation by putting the create methods in all of my custom classes where I inherit the engine classes. And then we cleanly decide if we want to add a pivot parent or not. Then in the actual create method that's shared, we can add that pivot joint like this. So this is really cool, works well. So we can now actually add a pivot joint or a powered pivot joint to two shapes. They should work. Let's try this. Oh, broke that one. And yeah, look at that. Very nice, very happy with that. And yeah, where we left off yesterday, the issue was in my pivot interaction, I had hard-coded to only do the pivot joint, but now we use the joint class here, and that's set through this method. Start with joint class, and this is what we use for the buttons now. These are still hard-coded, but that's fine for now. For the modules and such, I just list all the created modules, and I think I'll do something similar for the pivot joints or for the joints in general. But this is fine for now. So very nice. But now I have the issue right here. The way to control the joints right now is not proper. It's only for testing. And it's just this keybind right there. What should be happening is that we traverse the shapes the same way as when we activate a thruster. We need to propagate through the shapes with control, and then we need to propagate to a fuel source from there and actually consume the fuel, and then we can activate the action. So same thing for the joints, and the joints are included in the traversing somewhat, but they're not a step. They only connect. So this joint right there connects these two shapes, but in the traversing, these are only two steps. And I was thinking another issue is if we want to have upgradable joints and make them cost something, we need to make them weigh something. But how do we make something invisible weigh anything? I was thinking we could add the weight to either shapes, but that's not gonna be correct. I found that we can actually just set sensor to true. I'm not even sure we need that, but it could be fine. So making one of the shapes here a sensor, we can actually make that shape ignore collisions. So what if we make this circle an actual shape and we make it not collide with anything, but then we can add weight to it based on its cost. Same as with the modules for the batteries and the thrusters and stuff. This is 27 kilos of scrap and copper. If this is a shape, then we can intuitively include it in the traversing as a proper step. And then we can add modules to the shape and then have a bit of special code if it's a joint shape or whatever. And then we move this temporary test joint keybind to an action just like the thruster action. I think that's a good plan. Just thinking, is this necessary for the next release? Not really. I could just keep this temporary keybind actually. So it's free to open and close. It doesn't cost any power. You don't need control. It's enough to just focus the shape and there's no mass to it. I think it's actually fine as it is because I'm afraid of, I guess it's scope creep where I'll never reach the release that I want. So I think I'll pause this. This is fine for now actually. But I'll know in the future when I want to fix this, we can make the joint a non-colliding shape. Yeah, all right. So let's actually, I want to just change the keybinds here to be Q and E, I was thinking. Let's just rename this something like that maybe. And then that should appear here now. Q and E, joint open. Yeah, well, opening and closing is relative terms. And then if they collide, it just crashes. Oh, we should just fix this code. If there's no body, active body, we just return. The built-in serialization from Pymunk is really nice and I'm starting to learn it now. And I'm utilizing it here when we create a new joint. I get the state and then I modify the state there when we move the joint body attachments around. Like here, if there's an anchor, one of them, then we need to get the new local anchor for the new body. And also if there's a face, we need to get the new face. But that happens after we create them because we need the actual angles of the bodies, and this is a built-in method for the joint there. Yeah, there's a bunch of stuff here and then actually automatically gets this custom field. I'm not sure how that works, but they do, and that's good to keep in mind. And I'm sure that's how it works for all the serialization in Pymunk. Very interesting. I should probably rely on their methods more with the rest of my serialization, but that's fine for now. I keep saying that, but it is. So anyway, now we have the power joint here. If we activate the zone, we can attach shapes here. It still works, and we can separate the shapes, and everything works. Nice. Okay, let's try this again. I've reduced the size a little bit of the boulder, so it's a bit lighter, and we now have 200k power and a bit less copper and scrap. I want to fit all the power. Yeah. That's pretty much perfect right there. Something like this. I can fit everything easily. There, that's pretty good. And let's create that pivot joint like so. So go for the same design, maybe a bit taller. How big are we going to be able to make that magnet? Yeah, not too big with this amount of copper. We've got 1 copper in the battery. Ooh, the wheels have a lot of copper. So if we reduce the wheel size, that's only 3 copper right there. We can make the battery larger. These are the kind of choices I want to encourage. Like, where do you invest the resources? This balance feels much nicer. So what if you only have 1 big magnet there? Create the powered pivot joint up there. And yeah, we only have some scrap left. Let's save this. Play. Oof, too much weight. Yeah, the wheels are pretty tiny now. It's like, what's the mass of this thing? 72 kilos, and the wheels only weigh 4 kilos. So they're gonna be very vulnerable. How can we reduce the weight? We can make this thinner. Okay, it's a bit lighter. So can we make the wheels any larger? Not really. It's a tiny bit. All right, well, let's see if we can make it down. Focus this, bring up the arm. Wait, can I use the arm? Oh, it's so heavy out there when it's extended. Because if I can bring the arm up, it's gonna be less leverage. Or I use it here. Yeah, look at that. Beautiful. And now this should be fine. Yeah. All right, how much power we got left? We used up a quarter. That should be fine. And now let's activate the magnet. Let's just toggle it there. Ooh. Wrong way. Yes. Oh god. That's oscillating. Let's see if we can rotate it around actually. Oh my god. This is so cool. Let's see if we can return. Please stay there. Oh, no. Keep it upright a bit, I think. Oh, wait. Right. Oh, don't go so fast. Oh god. We're fine. Okay. Think about this. Come on. So much going on. It's hard. All right. Ooh. Okay, we're fine. And now I want to turn off the magnet. We're still draining the power there. Toggle magnet. No. Push it up. Bring the arm up. Oh my god, I did it. Oh, that's so cool. All right. And now we can pause. We can focus here. And now we have the boulder and we can delete it. Currently have 35 scrap and then we delete that one. We have 42 scrap. It works. Oh, that's so cool. Now that we succeeded, let's save the game. This car is so scuffed. Pretty well balanced though. Like, you do this, sure, but you kind of control it. If we go up here. Wait, I can... No, 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 no. Oh god. Would it be nice to be able to turn off the left wheel now? Because we're wasting power there. Yeah, we're out of power now. And yeah, the power gyro still works. That's just for the MVP now. But damn, that's so cool. I'm very happy with this. This has been my vision for the last month, and now it's actually it's working. Very cool.